In this video, we are going to learn about mass and weight. In our day-to-day lives, we use these terms interchangeably, right? But in science, they mean different things. So let us understand what they are. Mass and weight, let us start by understanding what is mass. Mass is the amount of matter in an object. What is matter? Matter, maybe you can say amount of atoms, the proton, neutron, electron, the amount of substance, the content in an object. Matter, the definition, simple definition of mass is the amount of matter in an object. Two objects of the same mass have the same amount of matter in them, be it solid, liquid or gas. We'll understand this point as we proceed with the video. The SI unit for mass, it is very important to understand the SI unit for mass is kg. Now this is a unit that we know already, it's not a new thing. Kg is the SI unit, and the instrument which is used for measuring the mass is a balance. I'll show you a picture of how the balance looks like as well. Let us now answer this question. You have 1 kg of iron, you have 1 kg of cotton. Which has more mass? My question is, you have 1 kg of iron and 1 kg of cotton. So my question is, which one has more mass? Which one of these two items that you see here has more mass? If you said that they have the same mass, you are correct. If you said that they have different mass, you are wrong. When you said that you have the same mass, why are you saying they have the same mass? Because if you see 1 kg iron, 1 kg cotton. Iron is dense. Iron is dense and cotton is fluffy. So same amount of matter or content is there in 1 kg of iron, though it is occupying a small space, right? Same amount of content or matter you have in 1 kg of cotton as well, though it's fluffy. Here the atoms, the particles are far apart in case of cotton. In case of iron, they are compact, close together, but otherwise they are exactly precisely the same amount of matter. If you put them on a balance, balance is the instrument which is used for measuring the mass. If you put both of them on the balance, you'll see that the balance will be balanced. It will be perfectly horizontal, right? So it is a very important understanding. Why? Because if you understand mass, you'll understand weight. Mass and weight are related. Let us now move on to understand what is weight. Weight. Weight is denoted by usually capital W. Mass is denoted by a M. So what is weight? The downward pull due to the Earth's gravity is the weight on Earth. It is a downward pull by the Earth's gravity. The formula for the weight. Very important to understand the second point as well. Let's go point by point. It is a downward pull. Pull is what? We have understood in the chapter force that pull is a force. Pull, push, they are a kind of force. So weight is a force. Very important for us to understand that weight is a force. Mass is not a force, weight is a force. But weight depends on the mass. Weight depends on the mass. And the formula which links the weight and the mass is this. The formula for the weight is W is equal to M times G. What is G? We have a chapter dedicated to G. G is the gravitational constant or the acceleration due to gravity. The value of G on Earth is 9.8 meters per second square. That's the value of G. The value of G differs from planet to planet, right? The value of G on Earth is different from the value of G in other planets, say Mercury, Jupiter, Saturn, or if you say Moon. So the value of G is different, so the weight is different from planet to planet. The mass does not change. The mass is an entity which does not change no matter where you go, no matter which planet you go to. If you are one person on Earth, say that you move to Mars, you are the same one person. You'll still have your two hands, two legs, the same body structure, right? The amount of material in your body, the amount of content, matter in your body is not going to change. So your mass does not change. The gravitational constant changes from planet to planet. It is the G, which changes. Mass stays constant. G changes, therefore when you input different value of G in the formula for the weight, mg, you get different weights for different planet. Say that the value of G on Moon is 1.6. 1.6 meters per second square. Your mass is say 50 kgs. This is your mass of 50 kgs. So what is your weight on the Moon? Weight on the Moon is 50 times 1.6, and weight on the Earth would be 50 times 9.8. So if you multiply the same mass 50 by two different numbers, you get two different weights. Your weight will be different. Your weight is going to be different on different planets. Now, what is the unit of weight? The unit of weight, if you see here, because it is a force, the unit of weight is Newton. So what is the unit that we put here? It is Newton. Your weight on Earth, your weight on any other planet is always represented in newtons. Why? Because weight is a force. Mass is not a force, right? Weight is a force. That's something you need to remember. There is a difference in the unit in which they are represented. Mass is represented in kilograms. Weight is represented in newtons. Please take care of this thing. It's very, very important, right? And one very important thing, the third bullet point. More is the mass, more is the weight. More is your mass, more is the weight. Why? What is the formula for the weight? Weight is equal to mg. So in this formula, if the value of the mass is higher, your weight is higher. If your mass is less, your weight is less. Right? Simple and easy to understand through the formula itself. Fine. Now the instrument which is used for measuring the force, the instrument which is used for measuring the weight is Newton meter. Even the instruments which are used to measure the mass and the weight, they are different. For mass you use a balance, for weight you use a Newton meter. Now here I would like to make one point. In our day-to-day lives, we interchange the meaning of these two terms, the mass and the weight. Suppose that you're going out in a vegetable market to buy some, say 1 kg of onions, right? 1 kg of onions. You say, you say in your day-to-day terms, you say that the weight of the onion is 1 kg, right? But that's not the weight. We should understand scientifically in science, what have you got? You have got a 1 kg of onion which has a mass of 1 kg, not weight. In our day-to-day lives, we use the terms interchangeably, that's fine. But when you are in science, you should understand the difference between mass and weight. Mass is the amount of matter in a substance and weight is a force. It is the pull due to the gravity on any planet. Because it is a pull, so therefore it is a force. The unit of weight is newtons, the unit of mass is kilograms. Alright, so let us move on and understand and see with our own eyes the instruments which are used to measure the mass and the weight. That's how your balance looks like. We all have seen it in our day-to-day lives. And the instrument which is used for measuring the weight is this picture. You'll find Newton meters in your labs, right? Newton meter is used for measuring the weight. Let us work this example. You can pause the screen for a moment and come back. Please pause. I hope now you all have solved the question and see if your answer is correct. Calculate the weight in newtons of a person of mass 60 kgs near the Earth's surface and parts pieces on the surface of the moon. The gravitational field strength near the Earth's surface is given to you. The gravitational field strength on the moon surface is given to you. So you are given the value of G. You are given the value of G on Earth. Let's call it GE, gravitational constant on Earth, gravitational constant on moon. So what is the weight on Earth? Mass multiplied by G on Earth. What is the weight on the moon? The same mass multiplied by the gravitational constant on the moon. So let us look at the working. Tally your answers. Alright, so let us move on to the next question. We have one more question here. An object has a mass 40 kgs on the surface of the Earth. State whether its mass and its weight would be smaller, the same, or greater on the moon. So please solve this question. Pause the screen. Solve question number A and B. In B, you have to calculate the weights. Pause the screen. Alright, so I hope that you all have solved the question. Let us tally the answers. Right, state whether the mass. We are on part A1. State whether its mass or its weight. Let's come to the mass. Mass part of the question would be smaller, same, or greater. We have understood that the mass does not change. So mass is going to be the same. Second part, how about the weight? How about the weight? Will the weight change? Will the weight change? Yes, the weight will change because weight is mg and g is smaller. G is smaller on the moon, so the weight is smaller on the moon. You need to understand moon is smaller in size as compared to the Earth. So G is smaller on the moon, therefore the weight is smaller on the moon. What am I saying? Let me write it. G on the moon is smaller than the G on the Earth. Therefore, mgm is smaller than the mass times the gravitational constant on the Earth. And what is this? This is your weight on the moon, weight on the Earth. Right? So what are you in for? Weight on the moon is smaller than the weight on the Earth. Let us come to part B. I am going to erase part A now. Part B. Calculate the weight of the object on the Earth and the weight of the object on the moon. Use the gravitational field strength given in the worked example, which is in the previous example. You can use the value of the G from here and you can calculate the weight, right, which is simple. Weight on the Earth would be weight on the Earth, let's call it WE, is equal to mass times 9.8. Weight on the moon would be mass times 1.6. And how much is mass here? Mass is 40 kilograms. You can input the values and you'll get your answer. So that's how you calculate the weight. You calculate the from the mass. That's how you calculate the weight from the mass. Alright, so let us talk about the term inertia, which is related to mass, right? What is inertia? Inertia is the resistance to change the motion. Inertia is the resistance to change the motion. You resist. You do not want to move, you do not want to change. For example, if a certain body is lying somewhere, for example, if I'm sitting here, I just am too lazy and I do not want to move, right? So this is called resistance. You do not want to change your motion, right? And important point to understand, more is the mass, more is the inertia. Let me explain this to you with the help of an example here. Suppose that you have two people. One has a greater mass. You see the person one in the picture has a greater mass. He's fat, right? Other person is lean, lesser mass. So if you are pushing the first person and if you are pushing the second person, who will move easily? The second person will move quite easily, right? He'll suddenly and very easily change his motion. If he is at rest sitting down, it is very easy to push and move the lightweight person as compared to the heavyweight person. This is what is inertia. The resistance to change the motion. The more is your mass, it will be more difficult to change your motion. So if a heavy person is sitting, it is very difficult to push and move that person. But if a lean person and a fit person or a very thin person is sitting, it's easy to push and move that person. Similarly, say if this fat person is already moving and if you push him, it will be very difficult to change his direction, to change his speed because he is heavy. Whereas if a lightweight person is already moving and if you push him, he might fall down, right? So changing the speed, changing the direction of the motion is also easy when the mass is less. So what have you learned? More is the mass, more is the resistance to change your motion. So more is the inertia. More is the mass, more is the inertia. More is the mass, you do not want to move, so your inertia is more, right? Let us understand with one more example here. A fully loaded lorry, if you have a fully loaded lorry, it takes longer to reach a certain speed than if it is carrying no load. So if you have a fully loaded, a lorry or a truck which is fully loaded, lorry or a truck with no load. So a fully loaded lorry will take longer to change its speed and reach its higher speed, whereas an empty or a lorry with no load will quickly reach its top speed, right? Why? Because the mass of a fully loaded lorry is more. More is the inertia. More is the resistance to change its motion and quickly gain speed. Lesser the mass, lesser is the inertia. Inertia is a very easy topic. Just straightforward relationship. More is the mass, more is the resistance to change your motion. Therefore, more is the inertia. So this video was all about understanding what is mass, what is weight, how they both are related, and about understanding inertia and mass and how they both are